tutorial using the Stream SDK inside our Unity games, where I will show you how to implement a voice call app. We will use specifically in this video the video and audio SDK for the SAT and other SDKs for other video. So first of all, let's show you the final output of the project. Then we jump to the tutorial and explaining the code. Before we start the video, I will show you what is the final output of this video. So like you see, there is my game. I will press run, go to settings. Here under start, we give and call ID. Then we stay in this music. And you will ask me why we stay in the music, because in this music component, this Canva hold the parent container of all the raw image and audio sources of the Stream SDK voice call image. There is it. Like you see here, there is a music panel, and here the content, we have the participant container. So always it needs to stay active in the scene. So when we join the call, we don't have problem. So after we join, we press play and we join the call. Like you see, here is it. Then we go to the iPad under settings, because we have in our device, we have plenty of camera, because we enumerate. I will show you in the code in future. We will see the camera back, because I don't want to show my face. We go to stage, we give the same call ID, so we join the same call, and like I said, we stay in the music panel. We press play. Here you will see the output of the output camera and audio of the iPad, and here you will see the output and the of audio of microphone and camera of the iPad. So we click join, green dot, and there is it. The output of the camera. I will make this like this. So there is myself. I move my hand, so the face time as the of the Mac work. Here the camera. So if I put my hand below, like you see my fingers. And if I speak here, you can hear. And hello, the sound from the both direction work. Like some will see that we have the problem of the echo cancellation and the loop back. This it need another video when we will explain the video optimization and audio optimization. So like I said, so there is the output in the console, that's the user joined, and the track added for the camera and audio. So like I said, now we will leave the call and start the tutorial. Like you see, we are here in the getstream.io. We go in the product, you choose video and audio, and in docs you will have all the framework listed that support the SDK. You go to Unity, like here, the first introduction. Then in the installation tab, you will get the GitHub URL. So you go here, Windows, Package Manager, Package. Then you click this small plus icon. Then you click the install package from Git URL, and you pass here the package. So I already downloaded. I have the version 0.8.1. I think it's the last version, and you need to have the Newton soft.json. It's a very important package. It's very important. And I even planned on using the StreamSide Unity SDK, so we can have a full tutorial about Stream SDK. But I found some problems, like internal GUID confusion, a version mismatch, especially between the Newton Soft package. So I stay with Stream Video, and I will in the next video I will choose another SDK about set messaging. So like I said, this tutorial is only video and audio call. About the message for the next tutorial. So like I said, when you download it, you will find it here, and this is a sample from it. So if you want the sample, all you have to do is go here and import it. Thus you can help you understand how to implement the code in your Unity project and understand the philosophy of the Stream SDK. So the installation is very easy. So after you install it, you need to set up. The setup you will need is only 3 scripts. The first script is here, the stream script. It takes care of the script stream initialization. This API, there is an API key for testing. I will change it when I will end the video. Then you have the stream UI script. This is take care of all UI interface, the logic between the UI and the data coming from stream. And here you have the last one is here under menu canvas, settings panel, the control area, and then you have this. And for the participant panel, you go in the under prefab and you give it. So you have a prefab, just an empty game object that holds reference to the script. So there is the 3 scripts. In my case, like I said, there is, let's make this scene window big so you can understand. Let's zoom. There is the area. So there is the panel. If you choose music, that means this. The music panel will be shown. And here under the content, where you will spawn the raw image that will hold the video data, and the audio source where you will hear all the other participants speak. So the setup is easy. You just need to understand how you want to show your video. But I found some problem here in 3D because the majority of application it will just have a random Canva 2D that will show the video. But in my case, I want to immerse it inside my 3D game experience, so the player can play, run, and at the same time click in this yellow button and speak and see the other participant. So the setup is easy, like I said. So after the setup, so let's go to we start with the first script. You have the URL, you have the stream client config, the iStream call interface, a small bool just to know if the call is already active or not, and 2 action the participant zone and left. Important when you enter and you leave a call. Here the authorization credential, you have the API key, you have the string user ID, you have the string user token. And this the main important is exposing the iStream video client so you can use it in other scripts. And here the iStream video call participant, because we are in the video call app. And here a dictionary, thus you need to keep track of all the audio source, and you will give him a key that is a string. And just this unit method is just a personal method, not a Unity engine specific method like awake. So the init, you will initialize the stream client config, and you will game the stream log level debug, so we can know all the problems that occur when we run a game. Then we start by creating a default client with this configuration client, and we will hold it in the client variable. Here in awake we call it first because we cannot access all the SDK functionality without the client. So when we have the client, we run a simple check. If we have the user ID and the stream token, so that means no need to fetch with server, because like you see in other tutorial, they will use and test token and user ID. But in my case, I want to mimic the production ready area. So with that, we need to have a backend server, and there is a backend server that my game talk with it. The moment it will want the stream token, it's called this slash token endpoint, and you will get your token, return it, and you need to use the stream client SDK in Node. Like if you go here, you'll find this. No, this is the stream sat. So like I said, and you need to have the stream sat in the server UI, because it's with the stream such where you can talk with user, add new user, give different role, or even escalate your privilege. So this backend, I will explain it right now. The user ID is a important variable that needs to be existing in the request body. If there is no user underscore ID, so that means the player didn't input his username, and we need his username to generate the token related to it. And in the first try block, if the processed user has user ID, that means this set. If it already have same user ID, that means already processed in the past, we upsert user with admin role. Just in case of the development, but in production we need the user role, not admin role. So we don't have the ID, we need to give it the admin role. We upsert with server client with same ID in the request plus with the role admin. Then we console that the upsertion is successful. Then we add it to the set, so next time we don't add redundant data of the same user. Else, already processed, we skip the upstairs because we already have the user ID. And here the token generated with the create token, and it needs the user ID. Like you see here, token, we can give it the expiry, that, and even the EIT, the importance it return a token. A simple console log to know the token with response for the server to know. And here if we catch an error, so like I said, there is a bucket endpoint you can copy. So here when we hit endpoint, we store the user ID and stream token in player prefs, because it's the go way in Unity to store data locally. Then we give the user ID and user token to get string with the respective key. Else we call the stream test endpoint. If we don't, so the first time we have no user ID, no stream token, we need to talk to the server so we can get our credential, so we can initiate the connection with the stream SDK. Here, a simple check if the three important variable user token, user ID, and API token are existing, not null or empty. And here we need to generate a credential with the auth credential, the three important. Then we connect to the stream async, the credential. Else, always try catch to detect potential problem. So there is the foundation, this awake and set is the foundation to have a working stream SDK. Here, there is how you call stream endpoint. We need to have a JSON data, because like you know the request is like a JSON format. So the JSON utility.json, we create, this is the login request. If we go to it, it's just a class that have a public string user ID, and an auto response. We know that the response only return a token. So when we have two classes, we know how to construct our request. So here we create a new login request that is user ID from the get string user ID, and this we get it if we press play. Under settings, in start, your username is Elias, because I already input here in the text area the name and I submit. So when I submit and I already have it turn off and we show the username. But in your case, when you start new, you will find a text area here when you need to put your username and click submit. There is in the request here and byte array of body row with uncode UTF-8 the JSON data. Like you know, the UTF-8 is the way to go in the formats. Here we use the unit web request and the method is post. We hit this URL. Here we upload handler the body row. Here the new download handler buffer. So here we construct the request body. Here the content type is important, is application JSON, so we don't have confusion with JSON data. And here we send the web request. If the web request is success, that means we got a response. So first of all, we get the download header text, that is all the response, and here we will format it. We will change it to be like auto response with the from JSON. Here we take the stream token, because the response has only one key token that holds the stream token data. We put it in the string stream token, then we set string the stream token in the stream token key, then we save, imported we save, and here we debug log the response JSON and stream token response for dev purpose. Else that means we got an error and we need to know it could be the server is down or just the JSON format request is error. Here, because this is an enumerator, we need to run it. So we run it inside this asynchronous voice stream that if you already have stream token registered in the device, no need to hit the database, the endpoint again. So just get the stream token and let's go. Else we start the coroutine this I enumerator. Here we connect to stream async. It only accepts odd credential and there is a try catch. Always await client connect to the asked credential. Here and here where we start the reading. The zone async is a task that need two parameters, the call ID and the create. The call ID is the name of the call so all the participants can join it, and the create we set it to true. First of all we check if the call ID is null or empty, so we throw this exception. Next we make the client, we call the client zone call async and we give it the type of default, the call ID, we set the create to true. So if this call ID is not an existing call, we create a new call with the same call ID, the ring true and notify false. And all this in the active call that is the iStream call interface. So then for each loop that we loop through all the participants in the active call participant, and then if the participant is local participant, that means I am the participant of the same device, we continue. Then we add on participant joined and this logic so we don't hear our save. Because there is the problem of the loop, so that your speaker hear your micro and repeat your own words. So this loop we need to escape it, and that by note if it is the local participant, we don't create an audio source of the same participant. Here is the on participant joined, we add the participant. Here we subscribe to the two events, the on participant joined and on participant left. We will explain this right now. Then it's very important to enumerate devices of the device, and like I said in the voice call audio we need the mic and the cameras. Here we loop it through the mics, and for each mic we run the select device mic and we enable it to true, so we activate it. And here a simple debug just to know the name of the mic and the selected one. Then we break. Here client audio device manager enable and the client video device manager enable. This is for the cameras. Like we have the mic enumeration, we have the video device manager enumeration, and we see the encode to true. Here a simple log that tell us we joined the audio. Then here is the task of when we leave the call. So that means if the active call is null, we already know that there is no active call, so we leave nothing. So we return. Here we unsubscribe from the two events, and here we call the active call leave async method. We make the active call to null, then in call false, just to avoid some data persisting between two different call to avoid problem. And here there is the two functions. The first one take a stream video call participant. So when the participant join, we invoke participant, and here on participant left we invoke the session ID just for the session and the control of the room or the call when we have a lot of participants. So this is the main functionalities, the important one. So here we go to the stream UI. Here when the all UI logic we have here, first of all the stream script instance, this one we have two buttons, the join call button and leave call button. In our case this one and this one, the purple is the join, and when join the call the red one spawn when we join. Then here the iStream audio device manager and video device manager instance holding the reference in these two variables. Here is the list, so we can render in the UI all the present devices, and the list it hold
the device info. Here the microphone device info, and here the camera info. It's a new list. All that come with the stream. So there is a stream video core in different library. Here is the call ID input. In my case, in this tutorial, user input his own call ID, then it's on the call. But in different case, the developer will already put the call ID in the code, hard-coded, so he can control which call the player can participate. But in my case, I leave it open. Here a dictionary. Just we know the already participant by their session ID. And here is the reference to the prefab participant panel. Is here, like I said, which will hold the raw image and the audio source. And here the participant container is just a transform that will act like the parent of this prefab spawn. So first of all, in start, we start by accessing the client object of the stream manager script. Here we call the audio device manager and video device manager of the stream client. We make the left button false, and we add the two listener, the on click add listener, on zone click and on left click for the two respective button. The drop down we clear option, so if we add it, so we can start new. If we add a new microphone or camera, so we can detect it. Here we call the enumerated devices in both the audio device and video device, and the result we add it in a range. That means the two lists that hold the device info. And here for the camera labels, for the UI, we only need to show the player the name, no need to all the data of the device information. So we select the device info and we only take the name, then we list it and we add it in the device drop down. And here we start we selecting only the first microphone and camera index from all the enumeration we get. Here the stream manager, and we subscribe the on participant left. And here the device drop down. If we choose another, if we selected another camera or microphone, we need to know that the value is changed, so we can call this method the on camera device change. So here we start with the on leave call click. This asynchronous, it will call the stream manager script and call his leave active call. Always await, because we need time. Here the button logic, what we will make it disappear and what will make it appear. Here any panel from the call participation of the value, we destroy this panogram object. So that means we destroy all related call object. And here we clear the dictionary for the new call. And if we catch an exception, here if we join the call, like always, the call ID input text must be full, not empty. We extract the ID from the call ID input text. Then we call the stream manager zone async method. We give it call ID and true if we don't have this call already existing. A simple debug to know that the call is successful. And like I said, the two button logic, what appear and what disappear, and always the catch to detect any anomaly. Here there is the on microphone device changed and on camera device changed. Like I said, they have the parameter the selected index, and here the selected microphone is the index of the list microphone device. So always in the beginning the index is 0, and here the audio device manager select device. So that means the audio device manager, it will check the microphone that is the one here with the respective index, and we enable it to false. Why? Because if we make enable to true in the beginning and this function is already called here, so when the player open the app, the game, automatically the microphone and camera turn on, and that is not a good user experience. The camera and microphone need to be turned on when you join a call, not when you open your game. And the same logic, the camera. So you have a variable that is a selected camera that hold the data of the camera device of the specific index. Like I saw in the intro, my iPad has more than 5 camera, so it holds the data of the first camera, then it passes as the selected device here. Because in the video I made the resolution small, so if you have a slow internet connection and you don't have a lag and you can see clearly, and like all I said, enable false. This on participant zone, like the stream script. If is local participant, we return, and here if a new participant zone, we associate the prefab under the participant container, and this prefab hold the audio source and data of the respective player. And here in this script I will show you how. Then we code init method of participant panel this script, then we add it to the dictionary so we can know which user, because the same user can connect from multiple devices. So the reality is the device camera is the real ID, not the username ID. So like my account can connect from iPhone, iPad and Mac, but the reality, even I am the same person, but the thing that I am connected with 3 cameras and 3 audio. So the Stream SDK treat each camera as a separate client. And here on participant left, we get the try get value session ID out to participant panel, and we destroy it, and we remove the session ID. So like I said, the stream UI logic participants, and here in the participant panel, like I said, you need to have a stream video called participant, and in it the participant you pass it will be holding in this variant. So the game object will give it a participant name, session ID, just to know it, and the track is a stream of data. It could be audio and image. So for each track in the participant tracks, we call this method on track added with this respective participant and the track from the for loop. And here we subscribe to on track added, and this method do what? So on track added, it accepts a participant and a stream track. So because it's a video call, we have image and audio, so we switch track. In case you have stream audio track, stream audio, you have a local variable audio source. We give it game object add component audio source, so we need to create a new audio source. Thus are important parameter for audio source, like enable to true, play on awake to false, volume to 1, space balance 0. Then you set the audio source target to this audio source. So this audio source, take this one and make it listenable, so we can hear the other participant. So because if you need to hear audio inside Unity, you need an audio source. So this audio source take the data and make it listenable. And here for the stream video track, you have a raw image. We create a raw image. If is null, we add the component, then we set it as the set render target, the texture of the raw image. And like I said, if participant is not local, we create this because it's not us, so we need to see it. This new video resolution, it must be similar to the dimension of the square raw image. And here default raw error, and here on destroy is important. You could find problem if you use my on destroy, because I still try to make it performant, because sometimes some old participant call data still lurk in the scene. So there is it. So I hope you like the tutorial. I hope you use it, and give me in comment your idea about the Stream SDK voice call. I hope if you find problem, you put the question in the comment section. I am very happy to answer you. So subscribe, like, comment, support me by downloading my calculator game in the App Store, and have a good day.